Hello, welcome to this lesson on the sine and cosine ratios for trigonometry. So the previous lesson we learned about the tan ratio, and this time we're going to learn about the sine and cosine, which are known as sine and cos. So we use a three-letter symbol like we did for tan, and we use sine, which is right here, and cos, which is right here. They're not pronounced sin and cos, which would be their phonetic pronunciation, but they're more representative of their actual spelling, which is sine is with an E and cosine, which is also with an E. We just call them sine and cos, okay? So you'll hear me refer to the three now as tan, sine, and cos. So if we look at the right triangle again, I can put once again, I'm going to put a reference angle in, and I'm going to, of course, mark my right angle here. And then I'm going to label my three sides appropriately. So this, of course, across from the right angle is my hypotenuse. Across from my reference angle is my opposite, and alongside it is my adjacent. Now, what we do here is we have two more ratios that we talk about. And the sine ratio is the opposite side divided by the hypotenuse side. So sine theta equals the opposite over the hypotenuse. And cosine is the adjacent over the hypotenuse. So if we take the cosine theta equals adjacent over hypotenuse. So we now have three, well, these are two additional ones. Of course, yesterday, I'll just write it over here, we had tan theta equals opposite over adjacent. And that gives us three ratios. And if you kind of do a little figuring on this, that's the three possible ways we can do it. We can combine A and O, which is for tan. We can divide O and H, which is for sine. And we can do A and H, which is for cos. Okay. Now they have this really kind of a simple saying that they say, which is Sohcahtoa, and it's Sohkahtoa. And what this really means is tan theta equals opposite over hypotenuse. Cos theta equals adjacent over hypotenuse. And tan theta equals opposite over adjacent. And they just use this little expression, Sohcahtoa, to help us better understand or remember the three ratios, okay? I do not make it a requirement to memorize them, and usually in the classroom I will have these posted on the wall somewhere so you can always see them. You're welcome always, even on tests in my class, to look them up. I don't believe that it's something that you need to memorize, but I do think that over time you will become really familiar with them. So let's just go down here and just say there are three trig ratios, okay? I generally write them in this order: tan theta equals opposite over adjacent, sine theta equals opposite over hypotenuse, and the cos theta equals adjacent over hypotenuse. And you do have to kind of keep these in your memory. The best thing for me to do is just do some examples and show you how we can use all three of these. Now, remember that the values for these, theta is an angle, okay? This is an angle. And these numbers here are side lengths, okay? And when we divide them, we get one number. So this is a side length, okay? And this, having a little trouble here. I'm going to erase that, clean my spelling up is terrible. Apologize. Whoa, didn't like me for some reason. Why is it doing that? I don't know. All of a sudden it's coming back. Doesn't want to disappear on me. Better not make any more mistakes. I apologize. Anyway, 2 side lengths. This gives me a number. And I want to refer you back to my trig ratio tables. So now you start to see this is the sine angle. This is the value of that ratio, right? That's the value of the opposite divided up by the hypotenuse. And the value of the adjacent for cos divided by the hypotenuse based on this angle. So, and then we have the tan opposite over adjacent right here. And these are all the values. When you're using your calculator like this, when you're putting in tan 42 degrees, what you're doing is you're just looking up on here the value of tan 42, which, you know, is like if I go down to 42, tan column is the third one. Tan 42 is 0.9004 right there, okay? So it's not like it's any rocket science here. This is just all the values put into the tables, okay? It'd be nice if I had one that fit nicely on one page. Unfortunately, I have to scroll up and down, but if you print a copy of this, which I've posted on the VLE, then that'll save you some time, okay? Of course, you have the option as well, just to use your calculator, and that's what I usually do. But I'm going to do both methods or explain both methods. Sometimes I'll use one, sometimes I'll use the other, and that way, you know, nobody's getting too tricked up. Okay, so let's do a couple of these, solve a couple things, right? So the first thing I want to do is label my sides with respect to the angle that I'm dealing with, okay? So if this is my angle that I'm dealing with, I'm going to get my pen back out, okay? Right here is my angle that I'm dealing with. That's theta, 60, okay? Then this here is across from the right angle. This is my hypotenuse, and then this is my opposite side, okay? Oh, didn't like me. I believe what I do is I touch the keyboard there on the wrong side, so we'll come back here. This is O right here. Okay. Now, what happens here is that what's happening here is I am using, these are the 3 values I have, theta, opposite, hypotenuse. And I ask myself, well, which one of the 3 equations uses theta, opposite, and hypotenuse? Well, it's the sine. So therefore, I need to use the sine. It has opposite and hypotenuse. Remember, opposite, hypotenuse. If I had a number over here, I'd be using the adjacent, right, and the hypotenuse possibly, or adjacent and the opposite. And then I would have to switch to one of these two depending on which it was. In this particular case, opposite, hypotenuse requires the sine theta, and you'll get good at this as you practice this. If you don't practice, yeah, it's a little confusing. So what do? I write down my equation. Sine theta equals opposite over hypotenuse. And now the next thing I want to do is I want to actually substitute in the values for each of these things. So theta equals 60. Hypotenuse is x, and opposite is 12. So I go sine 60 equals 12 over x. Now, I'm in this situation where x is on the bottom and I want it on the top, so I have to play the old switcheroo game, and I can write this as x equals 12 divided by sine 60. Now there's 2 ways I can find what sine 60 is. I can use my calculator and type in sine 60, or I can go to my table, right? My trig table. 60 is the angle, so I look up 60 right here. Sine is the first column, so the answer is 0.660. 866. My eyes aren't working very good today. I'm just going to zoom in a little bit there. There it is, 0.8660. So I can now go back here and change this. I'm going to just write this. Oh, I got to put my pen back on. I'm going to write this up here, and I'm going to say x equals 12 divided by 0.8660. And the next step, I can do the math and calculate this. So if I turn my calculator on, now you can't actually see me doing this, but I'm turning it on. 12 divided by 0.8660 equals, and the answer comes out to 13.8568. So I'm going to round off to one decimal place. So it's going to be 13.85, going to be 13.9. So it's 13.9, and I'm going to include my units. Put a box around it, and I'm all done. Now another option is to go straight from here to here. I don't have to write this step in, and I simply just type in 12 divided by sine, and I put 60 in, 60, and equals, and the answer comes out to the exact same number, identical, right here on my calculator, okay? 13.856 again, so I can write that answer down, okay? So that's one sample. I'm going to do another one. I'm just going to draw a line here so you see that this is the solution on one side. Here's the solution on the other. I'll even use some space over here. So look at this. This is my theta because that's where it's given me an angle. This here is opposite the right angle. That's my hypotenuse. And this here is my adjacent. Oh, now I have adjacent and a hypotenuse. And if I go back up and take a quick look at my three that I have, which one uses adjacent and hypotenuse? Well, it's the cosine law. So, cosine ratio, not law. There is a cosine law. That's something completely different. So I'm just going to erase my little erasing here and see if that keeps it away. Yep. And I can now do my work. I can do it over here because I got a little bit of room here. I'm going to say cos theta equals adjacent over hypotenuse. And I have to write that. That's going to be good for a mark. Okay. The next step is to do my substitution. Okay. Substitute stuff in. Okay. And what do? I say cos 42 equals x for a over top of h, 13. That's going to be worth a mark. Okay, and then I'm going to solve this. Okay, so if I bring the 13 over to the other side, just multiply both sides by 13, I end up with getting what's called x equals, if I just multiply both sides by 13, and you can do this, right? You get 13 times cos 42 equals x. And usually we write it on the other side, but I can save that to the last step. Now I can simply look up cos 42, right? I can go to my trig tables, go cos is the middle column, okay, just so you can see cos up here is the middle column. Don't get confused because there's lots of numbers here, lots of columns. And then if I scroll down to 42, cos is 0.7431, okay? And 0.7431. So 13 times, oh, I don't do as well when I get close to the side. I apologize. There we go. See if I can do this without 13 times 0.7431 equals my x. And I'm just going to say now what x equals, which is going to be those two numbers multiplied together. And I can also just do 13 times, and if I have a scientific calculator, cos 42, because it's going to, the calculator is just going to do the lookup for me. When I went to that other page and looked up the number, the calculator just does it for you. It's just kind of cool, right? And I say equals, and I get the answer of 9.66. So if I round that off, it's going to be 9.7. So 9, whoops, silly me. My mind is thinking ahead. 9.7 89.7, and I should include my units. And there I go, I'm done. And typically I give a mark for this, getting the answer, a mark for substituting, a mark for writing the right cos, and 1 mark for labeling the triangle. So a total of 4 marks there. I can do the same over here. 1 mark for the labeling the triangle, 1 for selecting the right formula, 1 for substituting, and 1 for getting the right angle. So even if you screw up getting the right answer, but you did everything right up until here, you still get 3 out of 4. I'm not even really putting that much focus on the actual mathematics of it. I want you to show me, demonstrate the other parts. All right, let's do some more examples. I've got 3 more examples to work on. Let's go with this one. It says theta is here. Okay, that means this is my hypotenuse and this is my adjacent. Well, which one uses adjacent and hypotenuse? Well, that's the cos. Okay, so it's going to be cos theta equals A over H. Okay, and then it's going to substitute. So mark for labeling the triangle, a mark here, substitute. Okay, so it's going to be cos, what is it, 32, that's the angle there, 32 degrees for theta, equals A, 105, over top of, x. I always label it x. Some kids just leave the big H in there, which is okay in many ways, but I don't know, I like to just kind of label it as a variable of something different, right? All right, so there we have 32, we have it substituted, so we got 3 out of 4 marks right there. Now it's to solve it. And remember, when x is on the bottom, we can play the switcheroo game, okay? And so this becomes x equals cos, 105 times cos 32. And then I'm going to solve for x. And I can look up cos 32 and just simply multiply it. Okay, so you get to a point where you don't write this down. So cos is the middle column, 32 is right here, so it's 0.8480. And sometimes I'll just go like this. It's going to be multiplied by whatever the number is. It was 105 times 0.8480 equals, and it gives me my answer to be 89.04. So in this case, 89.0 is acceptable answer. Or even if I wanted to just write 89, I'm not going to mark you wrong for that. So the answer is, I've got to get my pen back on, sorry, 89.0, and it is kilometers. And I love it when students do this. They box it for me. They make my life easy because I can look for your answer. There we go, all done. Now we have to do one where we have to find an angle, so I'm going to do a couple like that too, right? So here in this case, theta is already given, so this would be the opposite side. We don't have anything there, so I'm not even going to label it. I'm going to say this is the adjacent side, and then opposite the right angle is H. So once again, A and H. Well, which one uses A and H? Oh, that's cos. So I write cos theta equals A over H. Again, always starting with the actual formula, okay? Then I'm going to substitute in, okay? And theta is just theta, okay? So I'm not going to change that. We're going to look up theta equals 5 over 9. Now, it's best if I actually do this calculation and I do 5 divided by 9 in my calculator and get the actual answer. So 5 divided by 9 equals 0.5555, okay? So, and I always write it with 5 decimal places, okay? It actually would go 4 decimal places. That would be 0.5556. It would round up at the end, okay? Now, my job is I have to find, and by the way, so marks, once again, just to go from a mark perspective, 1 mark for labeling the triangle AH and theta, which was already done, 1 mark for selecting the correct trig ratio, and then 1 mark for substituting, and now another mark for finding the actual answer, which we're going to do here. How do I do this? Well, I can do it on my calculator, but it's actually kind of easy to do also on the trig tables. So watch when we do the trig tables. I have to remember that number, right? 0. If I want to write it down here, I could, right? Like I can go like this. I can go, watch this. I can go 0.5556. This is what I'm looking for, and it's in the cos column. Well, I'm looking down the cos column, which is right here, and I'm looking for a number as close as possible to that. Well, there's 5543. That's pretty darn close. So I'm going with 29 degrees. That's what the actual angle of theta is. So see how I take this number, I go down the appropriate column. Oh, that was the tan column. I apologize. I did the wrong column. This is a big mistake, easy mistake to make, right? I need to go down the cos column. So I look down the cos column. Oh, these numbers are getting bigger. That's the middle column here. It's going up is getting bigger, so I got to find a way to get smaller. Well, over here is another cos column for the other half. So there's the cos column, right? And I'm looking for 0.55. Oh, there it is, 0.5556. It is actually 56 degrees. So there's my answer. So when I go back to the other sheet, I go in here and I can say theta equals, and put my pen back on, 56. Oh, I screwed up again, my bad. 56 degrees. Apologize, sometimes I just touch the wrong spots. 56 degrees. And again, on angles, I'm only interested in getting to the nearest degree. And again, I like to see students write a box around it. There's your 4th mark. Okay, so if you were able to do all the other parts and still can't figure out how to get the degree, you can do that. Another way to do it is using your calculator. If I turn my calculator on, I can do something called second function, or shift in my calculator, shift cos, and then it comes up where I can put in the value 0.5556 and say equals, and it will give me the angle. And again, it gives me 56.2, which is really just, I'm going to write as 56 degrees. So we had it right off the tables, and now we've got it here. Okay. Okay, let's do another one. Again, another one with an angle. Oh, look at this one. This is theta. So this is my hypotenuse, which there's no number there. So this is opposite and this is adjacent. Which one uses opposite and adjacent? Oh, if I think it through, that's my tan. Tan uses O over A. So I write tan theta equals opposite over adjacent, okay? And now I substitute my values in, and I get tan theta equals 5.2 over 6.7. And notice I don't use units here. I'm not really that worried about it. Now I'm going to go to my calculator, and I'm going to divide 5.2 divided by 6.7, and I'm going to get my answer, which should be something like 1. Is it 1? No, it's less than 1. It's 0.7761. So I write that down, 0.7761 tan theta. Now I want to look up on the tables, or using my calculator, which using the shift function, the reverse function on here, I call it kind of like tan -1, they call it. It's kind of backwards function, but what was that? Oh, sorry, I apologize. 0.7761. Sometimes I like to write them down here because I get in trouble. So if I start tan and I notice, oh, the numbers are increasing, but I'm not up to 0.7, I'm only up to 0.3 here. 7.7 is what I'm looking for. I'm up to 7.8. Oh, there we go. 7.7. I had. I'm just going to write the number down. Come on. 0.7761. and I'm in the tan column, and it goes from 0.75 to 0.78. Ooh, it's kind of like, where is this? Well, 0.77 is closer to 0.78 than it is to 0.75, so therefore I have to go with 38. And sometimes you'll get one that's like right in the middle, and it's really tough to figure out. Well, you just go with your best, what you think is closest, and you pick the one it's closest to. If you're off by 1 degree, I'm not usually going to give you a lot of difficulty. I'm going to still give you the mark. So in this particular case, I'm going with 38 degrees, and I'm going to put my answer in as 38. So turn my theta equals, oh, I don't like that when it does that to me. Sorry. Here we go. Pen's on still. Okay, and I'll box my answer. And this is how you would do it. This is how I'd mark it. 1 mark for labeling there, 1 mark here, 1 mark, and 1 more mark. And that is essentially all your trig ratios. So today's worksheet, you could have anything, tan, sine, or cos questions on there. So you have to be able to break it apart and figure out which one you use in each situation. Okay, hope you enjoyed. If you have questions, please don't feel free to, please don't hesitate. Contact me and I'll help you any way I can. All right. Trigonometry.